Hello, Aiden. Today is Monday, the 19th of August. Is that correct?
Yep.
This is Math 1, and we're going to talk about significant digits today. What is our current learning goal? Aiden. I don't know why I keep calling you Aiden, but hey, Aiden.
I can use units such as feet and gallons to find reasonable solutions to real-life problems.
Micah? And why? Cool. So when does this ever get used? So what I'm about to teach you actually gets used in engineering. I want you to look at these two measuring devices. Here's a ruler, here are some calipers. Which one do you think is more precise? Which one can get you a better answer there? Go for it.
A caliper?
Calipers. So what we're talking about, significant digits, they're directly tied to what we're using to measure. So it's directly tied to either like a ruler or calipers or some kind of crazy laser measuring thing. Significant digits are directly tied to the measuring device. So we're going to start with some measuring. I'm going to give each of you a piece of paper, and you also need a ruler with centimeters. If you do not have a ruler with centimeters, I will get you one. You're also going to need your calculator. Aiden, will you hand out rulers? They have to use rulers with centimeters. So walk around. If someone needs a ruler, give them a ruler. Okay. And you know what? Get your own piece of paper. I need one blank piece of paper. If you rip it out of your notebook, don't have the little finger things on it. A separate piece of paper.
You need one? Use notepad or anything.
Any kind of paper you want.
Ruler.
After lesson, remind me to do a supply check. You remind her to remind me to do a supply check. All right. So you have a piece of paper. What I would like you to do is I'd like you to measure the length and the width of it and write those two numbers on the piece of paper. You're measuring length and width in centimeters. Measuring length and width and writing it on the paper. Chris, you got a length and width? You're going to be a little bit louder for me. I'm all the way over here.
26.5 for the length.
26.5, okay, and?
18.5 for the width.
Thank you. Anybody have a different? Yes, go for it, Jackson.
For the length, or sorry, for the width, 21.5. For the length, 28.
28 point.
Hard stuff.
28.0 then?
Oh, yeah.
So right there, I want you to see something just happened. When you gave me 21.5, okay, that sounds good. When you gave me a 28 and stopped, it was like, hey, is there more to it? And you're telling me there's not. But the 0 actually tells me something, doesn't it? It tells me that it's at 28, boom, dead on.
Oh.
So notice that 0 tells me something. When you just say 28, I was like, 28.0, it's dead on. We're going to come back to that in a second. What do you got for me, Eli?
For the length, I got 26.3, and for the width, I got 18.6.
Okay, that's good enough. If you have something different, that's fine. Looking at the ruler that you were using, most of you, it looks like you could get to 1 decimal place. You could go 18.5 with this ruler. Was that reasonable? 18.6? 18.0? 28.0? You could do that. Why didn't you say, I don't know, 21.53? Gavin's saying because you can't be that exact or precise. This thing doesn't get that good, right? Do you think if I had another measuring device, I could get that good? Yeah, some kind of there are measuring devices out there, yes. This is only good to 1 decimal place. Are there measuring devices that can do 2 decimal places?
Yeah.
Yes. 3? Yes, they exist. This is good to 1 decimal place. I want you to multiply your length and your width together and get an area for me. Jackson, this one's yours, I think. What's your area?
Oh, 463.
All right. So I'll find your area and write it down on the paper somewhere. Who was this? Chris.
490.25.
490.2. Jackson?
602.0.
602.0. That doesn't, yeah.
But yeah.
When you do 28 times 21.5, you get 602. Okay? Just 602.
Yeah.
This one was this, Eli?
I got 489.18.
489.18.
Yes.
How many decimal places can I take this ruler to? 1. This ruler is good to 1 decimal place. So how then can I suddenly get an answer that's good to 2 decimal places? The ruler is not precise enough. The ruler is good to 1 decimal place. And suddenly by using my calculator, and because I'm telling the world, I can only get to 1 decimal place. I can only get to 1 decimal place. But then magically, now we've got 2 decimal places.
Because the calculator is more precise.
But how can I suddenly get more precise than the thing I used to take the measurement?
Because we were only doing
And the correct answer is I can't. I can't suddenly get more precise than this is what I use to measure it. By doing a calculation, it doesn't suddenly become more precise. You guys like to ask me, hey, how many decimal places should we take things out to? And I usually say take it out to 1/10. Today you're going to learn, based off of the actual numbers, how the rounding has to go. The correct answer here on all of these are the correct answers right there based off of that ruler. I'm going to explain how I got to those numbers right now. So what we're looking at is how do I accurately round something based off of the numbers that were given to me and the measuring device that I used. And this is what significant digits are. So here we go. Questions so far. I haven't taught it yet. I'm just getting you ready. I'm going to teach you how to properly round in certain instances. We did that. And I taught you how can the area become more precise than the ruler used to measure the paper? It can't. So these are the rules for significant digits, also called significant figures, or sig figs. So this is all going to go in the notes. Rules for significant digits. So these are the rules for significant digits or sig figs, or significant figures. Digits, figures, same kind of thing. Rules for significant digits or figures. First rule, all non-zeros are significant. Oh, what does the word significant mean to anybody? Significant. Go for it. Important. So which numbers are important? That's what we're looking at. So which numbers are important? All non-zeros. That's numbers 1 through 9 are significant. And when I say significant, I mean important. We have to, those are valuable numbers for us. All non-zeros, 1 through 9, are significant, important. Jackson.
What about, cause like, what about like 11, like 12, 13?
Those are, yeah, well those, it's made up of 1 and 2. So those are both important numbers for us.
Okay.
So 11 is really a 1 concocted with a concatenation. A 1 and another 1, right?
Yeah.
Okay, it's different from 1 plus 1, but yes. All trapped zeros are significant. So trapped zeros, and I'm going to explain this more. Trapped zeros are significant. Always significant. Trapped zeros are always significant. I'll explain what trapped zeros are in a moment. We're going to get the rules down first. Trailing zeros with a decimal, trailing zeros when there is a decimal are always significant. Trailing zeros when there is a decimal are always significant. Trailing zeros when there is a decimal are always significant. Leading zeros are never significant. Trailing zeros, when there is not a decimal, are ambiguous. Ambiguous meaning you can't really tell. All right, get those rules, and now we're going to start applying those rules. I'm going to give you 30 seconds to catch up while I take attendance. Am I missing anybody today? Look around. I feel like I'm in class. So here we go. 2, 3, 4. Is the 2 important?
Yeah.
Is the 3 important? Is the 4 important?
Yeah.
So how many of those numbers up there are important?
All 3.
3. This is 3 significant digits, or 3 sig figs. $2,004. Is the 2 significant?
Yeah.
Yeah.
Is the 4?
Yeah.
Are the zeros?
No.
Yes.
Yes.
Maybe.
Yes.
Yes. What kind of zeros are these? Raising a hand. Who thinks it based on the rules?
Trap zero.
These are trapped zeros. They are important because they're bookended by 2 natural numbers. So this is 4. Why? Because of trapped zeros. .00. Is the 6 significant?
Yeah.
Yes. It's a natural number. It's one of those. Yes. Are the zeros significant?
No.
Yes.
Well, the question is this. Are they trailing zeros? Meaning, are they coming after a natural number?
Yeah.
Yes. So they are trailing. They're trailing zeros. Is there a decimal?
Yes.
Yes. So these are trailing zeros. When there is a decimal, they are significant. So this is 3 sig. I'm going to give you another one that's not up on the board yet. I'm going to go $40.00. You're going 3. How many sig? Hold it up with fingers. I like this. I've got some 3s. I've got some 4s. Got a 2. First off, is the 4 significant?
Yes.
That's 1. Are these trailing zeros?
Yes.
Yes. Trailing zeros mean they're coming after the natural number. Doesn't mean that they're coming after the decimal. It means they're coming after the natural number. I have trailing zeros. Is there a decimal?
Yes.
So are those trailing zeros significant?
Yes.
Yes. What this is telling me is that my measuring device could get to a .01. This is telling me my measuring device can only get to that. It can't go a 0.5 or something. This is telling me something about the measuring device I'm using. So this is 4 sig. All right, how about 4,500? Is the 4 significant?
Yes.
Is the 5?
Yes.
Are the zeros trailing?
Yes.
Well, they are.
They are trailing zeros. Ready? Trailing zeros when there is no decimal. Is there a decimal?
No.
So what can you tell me? Go for it, Jackson. Use that fancy word. I don't know. It's 2 or more. It's ambiguous. There are at least 2. It might be 4, but I don't know. I can't tell based off of this. So this is 2 ambiguous. At least 2. Because I don't know about my measuring device. Could my measuring device have gone 4510? I don't know. Could my measuring device have gone 4511? I don't know. Maybe my measuring device could only do 4500 or 4600 or 4400. I don't know without looking at the measuring device. It's like a scale. Maybe this is a scale that measures trucks. And the scale itself, when I put a big truck on it, it says 4500. I put a little truck on it, it says 4400. Maybe it can't even measure that precisely. So I don't know what's going on with this thing. Maybe these are tons. Do you think something that could measure 4,500 tons could get down to 4,500.01 tons? No, right? Now, if something that could measure milligrams, do you think it could go down? It tells us something about the measuring device. And then, how about this guy? 0.006. Is the 6 significant? Yes. Are the zeros leading or trailing? These are leading zeros. What can you tell me about leading zeros? Never. So how many sig figs here, Gordon? One. .0890. What can you tell me about the 8 and the 9? Significant. Are these leading or trailing?
Leading.
Leading. What can you tell me about leadings? They're not significant. What can you tell me about this trailing?
It is.
Why is it significant?
There's a decimal.
Because there's a decimal. It's trailing and there's a decimal. So how many sig? 3 sig. Whiteboards and markers, please. Got it. That's all right. Right, let's start with A. On your whiteboard, just give me a number. How many sig figs right there? Letter A. Letter A. Nice. Good, 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 good. Good, good. Then we got good, 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 good. Good. Okay, and let's see. There's a good reason for them to be on better. Good. Good. What's going on over there? You have a marker? Okay. Can you borrow one? And then what do you have? So I've got this as 4 sig figs. Good. Next one, B. Good. Good, good, good. Good, good. Letter B. Good. Good, good. Good, good, good. Good, 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 good. 5 sig figs. Letter C. Give me some. Because I don't know if it's 2 or not. I can handle that. I can handle yours. Yes, yes, yes. Yes, yes. 2? Maybe it's 3, maybe it's 4. I don't know. So I would call this as too ambiguous, or at least 2. It's definitely 2, right?
Yeah.
1, 2, but those guys right there, they're trailing without a decimal. Trailing when there's no decimal, they're ambiguous. I don't know. I don't know if this measuring device could go down to 7801. I don't know. Maybe it's only good to 7810. I don't know. 2 minimum, but it's ambiguous. Questions on the ambiguous? We know it's at least 2, or 2 ambiguous. What are we on? D. Good. I'll start on this side. Good. So a little chunk here. Good. You? I'm going to come back. Yeah, good. Good, good, good. 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 Come back. Good, good, good. I'm going to do third out. Good, 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 good. 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 5. Why 5? Decimal of trailing zeros. E. Okay. Good, good. No. Good, good. I'm going to talk to you. We'll figure out. Did you get good?
Yeah.
You did. Good. Good. This guy right here, is the 9 significant?
Yes.
Is the 8?
Yes.
Okay. Are these zeros?
Yep.
Why?
They're trapped.
Trapped. This guy right here, what kind of zero is this?
Trailing.
Trailing with a decimal?
Yep.
So is he significant?
Yep.
6 sig figs. F. Nice. Now we're, yeah, that's it. Perfect. Good. At least 2, right? So 2 ambiguous. Good, 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 good. At least 2, 2 ambiguous, 2 or more, at least 2, good. And letter G. You can't see. What about on your screen? Is my camera blocking yours too? Okay, good. What about that? How many? You say 4. Why do you say 4? Tell me about the zeros. Are they leading or trailing? Leading. What can you tell me about leading? Good.
Is activities.
They're leading. No, but leading and trailing is not based off of the decimal. It's based off of the natural number. Are those zeros coming before the natural number or behind the natural number? They're before. That means they're leading zeros. They're leading zeros. Good. They're leading zeros, which means 1 sig fig. So going back to that paper thing, your final product cannot have more significant digits than the least significant number in it. So if I'm multiplying 2 numbers together, and this one has 3 sig figs, and this one has 2 sig figs, my final answer can only have 2 sig figs. I can't get better than my least significant digit. Think about it like this. On a team, you're only as good as your worst player. On a chain, you're only as strong as, you guys know these analogies? The weakest link. Have you heard that? You should hear that. A chain is only as strong as the weakest link. On your values here, your answer, your final answer, it can only be as good as your least significant starting value. So if I have something with 5 sig figs, and I have something with 3 sig figs, when I multiply them together, how many sig figs do I end up with? 3. If I have 5 sig figs and 1 sig fig, and I multiply them together, what do I end up with? 1 sig fig. You're only as good as your least significant value. Let's do some multiplication here. How many sig are here?
2.
How many here? 2. When I multiplied, what did I get?
3.
3. But I should only have 2. So let's take this down. So 18.7 becomes 19.
Oh,
So I round it. I round it at the end. How many sig figs there?
1,
How many here?
3,
My final answer is only good to 1. So I can't round it. I've got to round it to 3,000. Now I realize this 3,000 is ambiguous, but I've taken it to what looks like 1 sig fig. Calculators? Multiply it and round it correctly based off of the significant digits. Multiply it and round it. And I will do the same. Beautiful, beautiful. Beautiful. Now you're working out the rounding. You did the multiplication, now you're working out the rounding. Good. I think I should see 3 significant digits on this. I think I should see 3. Good. 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 When I multiply, I get 15.732. But now I have to think about the sig figs. How many sig here?
3.
How many here?
3.
So I should end up with 15.7. Do the next one. 607 times 92. Perfect, Chris. Like a magical number. A mathematical number. Excellent, Bradley. Maddie, well done. Look, you're all getting compliments and stuff like that. So final answer should be 2 significant digits. That doesn't mean you can take a number like 55,000 and shrink it to 55. You still got to be doing it. So I've got this, which is around 56,000. No, this is 5,600.
Oh, yeah.
You need one more zero. Good. I'm not asking how many six, I'm asking for the actual answer. Good, good, good. So now we want to take it, so I've got 2 numbers. So this is going to round to 56,000. It rounds to 56,000. So when I multiplied it, I got 55,844. But I'm only good to 2 sig figs, which means all these numbers down here need to go away and turn into zeros. So I'm going to round this up to 56,000 because now it's got 2 sig figs. Do the next one. Got it? Good. Good. So are these your tunnels? They go underneath. Are you aware of that? So I'm not going to let you do silly math notation. We're going to use the correct math notation. I think you lost the 0. That looks good. So how many sig figs are in your answer? I should only have 1 sig fig because of that 200. That 200 only has 1 sig fig. So you got to round this to 1 significant digit. Good, 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 good. Like it, good. Good, good, good. Aiden, good. Good, I'm just looking at your zeros. Perfect. Good, good. Nice. So this is what I got when I multiply the same thing, but I can only have 1 significant digit. So the only number I get to keep is the 1, and everything else has to change to zeros. Letter D. Excellent, excellent. You guys, yeah, well done. You guys are on it, catching it. It's good. No, and then we're letter D. How many sig figs do you have there? On the board, on the whiteboard, how many did you show? That's 2. Got it. Okay, yeah. How many sig figs? How many sig figs are there? Good, good. How many sig figs are you showing me right now?
I'm trying to show you 3. confused.
No. Yes. So let's do the multiplication. When I multiply it, I get 1602. Is that cool? There's the multiplication. How many sig figs are right here?
One.
1. So I need to take this thing and I need to round it to right there, which means it's going to round to 2,000. Because I only get to keep one significant digit in my answer. What does 101 squared mean? Okay, so this is what you're really doing. You're doing 101 times 101. Okay, do that for me. Should I come look at it? Start on the homework. You took the 1 sig fig, it wants 3 sig figs. Okay, so you got 5 sig figs and it only wants 3 sig figs. It wants 3 sig figs and you took it to 1 sig fig. Good. You took the 1 sig fig, it wants 3 sig figs. You took the 1 sig fig, it wants 3 sig figs. That's good. Start on the homework. Start on the homework. You put 2 zeros somewhere in your edge. Look at your calculator, you got the password. Now you're showing me 5 sig figs and only wants 3 sig figs. That's it. You lost the zeros there. Right? So 1 0 2 0 0. That's good. Start on the homework. That's good. That's good. That's good. That's good. You'll throw it away from here. That's good, Gavin. And you guys can start on the homework. I'm going to come check supplies. I want to see a calculator, a dry erase marker, a pencil, and a notebook. All right. Anybody going to come here and tell people at home what to do? Have you done it before? Have you done it before? Come on up. Come on. All right. Look at the camera and tell them what to do.
Make sure you like and subscribe.
Yes. Can we point to the buttons they're supposed to push? Is there a button right there? Well, it's like, look at the camera. Where's the button?
Yeah, it should be like right around.
Right. What side's it on? Look at us.
Here.
Where? Right here? Right there. Right there. I think it is right there. We'll do better tomorrow. All right. Hey, thanks for coming to class today. Bye-bye.